All right, this is section 4-1, congruent figures. So we're going to start off with some vocabulary review. We're going to underline the correct word to complete the sentence. So a polygon is a two-dimensional figure with either 2 or 3 or more segments that meet exactly at their endpoints. And the correct answer is a figure with 3 or more. All right, next question. Cross out the figures that are not polygons. So this oval here is not a polygon. Okay, it does not have segments that are composed of its sides. This is not a polygon because its figures are, the sides cross, so they do not cross. And this is a three-dimensional figure, so that is not a polygon. So our only two polygons are these two figures in the middle here. So, adding to our vocabulary, the word congruent is an adjective. Congruent figures have the same size and shape. A related word would be congruence. All right, let's use that vocabulary. So we're going to circle the triangles that appear to be congruent. So which triangles appear to be the same? Well, these two triangles appear to be the same size and shape. Okay. All right, now let's write true or false. So congruent angles have different measures. Well, that's false. In order to be congruent, it must be the same. All right, 5. A prism and its net are congruent figures. This is false. They have to be the same. So a prism is not the same shape as a net. 6. The corresponding sides of congruent figures have the same measure. That is true. All right, so key concept, congruent figures. So congruent polygons have congruent corresponding parts. They're matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. So in the figures over here to the right, we have two polygons. We have polygon A, B, C, D, and we say it's congruent to polygon E, F, G, H. Notice the way we named them goes in the same order. Okay, so use the figures at the right to complete each congruent statement. So line segment AB must be congruent to line segment EF. Now, we can look at the picture to help us, or we can look at the name statement. Notice how AB shows up first. EF also shows up first. So that's how I knew it was going to be congruent. All right, let's go down. Angle A must be congruent to angle E. Line segment BC must be congruent to line segment FG. Angle B must be congruent to angle F. Line segment CD must be congruent to line segment GH. Angle C must be congruent to angle G. Line segment DA is congruent to line segment HE. And angle D is congruent to angle H. Okay. So, problem 1. If triangle WYS is congruent to triangle MKV, what are the congruent corresponding parts? Okay. So let's use the diagram at the right. Draw an arrow for each vertex of the first triangle to the corresponding vertex of the second triangle. So W corresponds to M, Y will correspond to K, and S will correspond to V. Okay. Number 9, use the diagram from exercise 8 to complete each congruent statement. So sides, WY must be congruent to MK, line segment. Line segment YS must be congruent to line segment KV. Line segment WS must be congruent to line segment MV. Angle W must be congruent to angle M. Angle Y must be congruent to angle K. And angle S must be congruent to angle B. Okay. Problem 2. So suppose triangle WYS is congruent to triangle MKV. If we know that the measure of angle W is 62 degrees and the measure of angle Y is 35 degrees, what must be the angle of measure B? So, and we're going to explain why. So number 10, use the given information to label the corresponding parts. So in the description, we were told W was 62 degrees. We were told y was 35 degrees. And this triangle statement, this must be S. Now, since we know W corresponds to M, I know this angle here must be M. Y corresponds to K, so this must be K. And S corresponds to V, so that must be V. So angle W is congruent to angle M, angle Y is congruent to angle K, and angle S is congruent to angle V. So we're going to use the triangle sum theorem first in order to figure out the measure of angle S. So measure of angle S equals the measure of angle V, or excuse me, measure of angle W, plus the measure of angle Y, which equals 180 degrees. So the measure of angle S equals 180 degrees minus 62 degrees plus 35 degrees. And then when we do the math, we get 83. So since we know angle S is congruent to angle V, and we know angle S from above was 83 degrees, we know angle V must also be 83 degrees. Okay. And let's try another problem. So if I know triangle ABD is congruent to triangle CBD, let's complete the following. So in order to prove two triangles congruent, I must show all corresponding parts are congruent. That means all angles must be congruent and all sides must be congruent. So we're going to circle the name for triangle ACD. ACD. If two sides of the triangle are congruent, this triangle must be isosceles. All right, cross out the congruent statements that are not supported by the information above. Okay, so the picture tells us AD is congruent to CD. Okay, base angles must be congruent, so angle A must be congruent to angle C. So that's true and that's true. We know a segment is congruent to itself by the reflexivity property. We were not told angle ABD was congruent to angle CBD, so that's not told to us. We were not told AB was congruent to CB. We were not told angle ADB was congruent to angle CDB. So you need 6 congruent statements to prove two triangles are congruent. So I cannot prove that triangle ABD is congruent to triangle CBD. Now what's cool is we're going to actually start adding some theorems here in a minute that might tell us we don't actually need to be told all this information because we can actually calculate or find some missing pieces of information that will allow us to prove triangles are congruent. So the first theorem that might do this for us is something called the third angles theorem. So the theorem states as follows. If two angles of one triangle are congruent to two angles of another triangle, then we know by default the third angles must also be congruent. So in symbols, if I know angle A is congruent to angle D and angle B is congruent to angle E. So notice my marks in my figure. A is congruent to D and two lines, B is congruent to E. Then, by conclusion, the third angles must be congruent. All right, so using the information above, if I know angle A is 74 degrees, I also know angle D is 74 degrees. If I know angle B is 44 degrees, I know angle E is 44 degrees. And if I know angle C is 62 degrees, I now know angle F is 62 degrees. All right. So if I was given angle A is congruent to angle D, notice how it's marked. Angle A is congruent to angle D. Line segment AE is congruent to line segment DC. EB is congruent to CB, and AB is congruent to BD. We want to prove these two triangles are congruent to one another. So do I have all the information? I have 4 pieces of the information. I need 6. So what I need is I need this angle congruent to this angle, and I need this angle congruent to that angle. So I'm given 4 parts of the congruent parts, 4 pairs of congruent parts. Circle the additional information I need to prove it. I need a second pair of congruent angles, and I need a third pair of congruent angles. So let's see if we can complete the steps of the proof. Okay, so trying to use this figure from above. Okay, from the given, I was told line segment AE is congruent to line segment DC, line segment EB is congruent to line segment CB, and line segment BA is congruent to line segment BD. I was also told angle A is congruent to angle D. Okay, now notice vertical angles, angles across from one another are congruent. So angle ABE is congruent to angle DBC. Now, I've now proven two angles are congruent. So by default, or the third angles theorem, angle E must be congruent to angle C. Now, 1, 2, 3, 4, 5, 6 pieces of information. I now have proven all 6 parts congruent. Therefore, triangle AEB must be congruent to triangle DCB by the definition of congruent triangles. All 6 parts are congruent. Okay. So, did we understand what we just did there? In each angle in one triangle is congruent to its corresponding angle in another triangle. Are the two triangles congruent? Underline the word to complete the sentence. To disprove a conjecture, we need one counterexample. So an equilateral triangle has 3 congruent sides and 3 60-degree angles. Circle equilateral triangles below. This is equilateral, this is equilateral, and this is equilateral. So are all 3 of these congruent triangles? No. Okay, so equilateral triangles have all pairs of corresponding angles congruent. But not all equilateral triangles are congruent. Okay. And that's pretty much the end of this lesson. So you should at this point understand congruency and polygons.